Hello everyone, Danai here from Danai's Electrical Services, and in today's video I will be explaining how a residual current device or a residual current circuit breaker works. You might know these devices from their abbreviation, which is RCD, which stands for Residual Current Device, or RCCB, which stands for Residual Current Circuit Breaker. As you notice, the common term for these two devices are residual current. So what exactly is residual current? Residual current can be defined as leakage current, right? So residual current, leakage current, or ground fault, they are all referring to the same thing. For the most part, that is. Right? So let me explain now what is leakage current. So once you have a live conductor, a live circuit or a live conductor, which is supposed to be live, which comes in contact with a non-current carrying conductor, which shouldn't be live, then you have leakage of current. Let me say that again. Once you have a live circuit which comes in contact with a non-current carrying conductor, then you will have leakage of current, right? You will also have leakage of current when someone touch a live circuit and complete the path to ground, side note, which will cause an electric shock. So let me go back to what I was saying now. So the side note is that that will cause an electric shock. Once you touch a live circuit and you complete the path to ground, you will get an electric shock. Worst case scenario, be electrocuted. Okay, back to what I was saying. So once you have a person coming in contact with a live circuit and they complete the path to ground, you will also have residual current flowing, right? So that is also leakage of current, and residual current is flowing, and that is also a ground fault, right? Speaking of ground fault, RCCB and RCD is used interchangeable. Those two terms are used interchangeable, as if they are the same thing, also along with GFCI. So RCD, RCCB, and GFCI, they are sometimes used interchangeable, as if they are the same thing. I somewhat agree, but not fully. I look at it as if an RCD is the device within itself, which is the residual current device, and then a RCCB, which is a residual current circuit breaker, and a GFCI, which is a ground fault circuit interrupter, are examples of RCD. So I look at it as an RCCB, and a GFCI is a type of RCD, right? Some people see them as the same thing, but I look at it as if they are a type of RCD, right? Hope I'm not confusing anyone here. So these are examples of the RCCB. Just going through some of the popular brands. We have Siemens right there, and this is a triple pole, so we use these for the 3-phase. We have this one here from Schneider Electric, another 3-pole. Now we have Chint. We have a single pole and a triple pole, and we have one here from ABB. As I said, just going through some of the popular brands so you can see what they look like. And we have here the Legrand, and as you can see on it, we have the test button So when you install it, you can test if it is working. Same thing for ABB. I mean, same thing for all of them. Test button. And my demonstration that I will show you, I might not have the test button. I might or I might not have the test button. And when this circuit trip, you can just turn it back on. Once the fault is removed, you can turn it back on, and the RCD will be back to working normal. So I will just now go ahead and try to give you like a graphical representation and a simple explanation, trying to simplify it as much as possible. A simplified demonstration of how these devices work, which are RCD, Residual Current Device. So let me just go ahead and show you that now. Okay, so now I will try to give you a demonstration of how these devices work. So this is our RCD, right? Or Residual Current Device. This is our source coming to the RCD. So this is our live and this is our neutral, right? We also have the live and the neutral and this end, right? And this will supply a load. Let's say this load is a light bulb. So our load is a light bulb, right? This is a lamp right here, right? I hope everyone is following me so far. This is our live circuit, this one right here, and this is our neutral. Let me go again. This is our live line and this is our neutral going back to the RCD. So all RCD has three things that they have in these devices to help them carry out their duty, and this is a summation current transformer, a trip relay, and a switching mechanism. So let me go over them again. Summation current transformer, trip relay, and switching mechanism, right? All RCD works with this principle or have these principles in place to become an RCD, right? How that summation current transformer works is that it constantly measures the current going out in the live, which is the source. So it constantly measures the current going out in the live and the current returning in the neutral. So the source going out and the return that comes in the neutral. The sum of this is supposed to give you 0, right? In normal condition, let's say we have 3 amp. Just throwing out some random figures here, some random numbers here. Let's say we have 3 amp, right, flowing into the lamp. In normal condition, you're supposed to have minus 3 amp flowing back through the return. So the sum of this, which is 3 plus minus 3, is supposed to give you 0, right? So the sum of current leaving and returning to the RCD should be 0, right? So that is the principle that the RCD works on, because under normal condition, whatever leaving the RCD in the live line should return to the RCD in the neutral line. That's it. That's standard. In a normal circuit, that everything is okay. Whatever leave in the live should return in the neutral. That's it. That's standard. That is how a circuit should be, right? The summation current transformer, however, it always, right, always make a check to ensure that whatever leave is whatever return, right? And once there is a difference, let's say, all right, let's illustrate things right here. So we have, this is our ground, right? As in the ground that you walk on. And this little boy, let's say, is standing on the ground, and this is his arms. How is he going to reach this now? Let's say he has a metal stick in his arm. He's playing with a metal stick, and he touched this live wire with the metal stick. He's a young boy. He doesn't know. It's that the metal stick that he has is a conductor, right? So the live wire is exposed and he touches it. Let's give him some excitement now. He touches it. This is his hair spanning out, right? Some amount of current will flow from this live wire through his body, through to ground, right? So you know what is going to happen? Some of the current, some of the 3 amp is going to go through that boy, and some is going through the light. So guess what? Not everything, not all of the 3 amp will go back to the neutral. So the summation current transformer will say, no, something is wrong. What I sent out is not what I get back. And just to simplify it, an excitation current will be sent to the AAA, and the switching mechanism will be activated, and the RCD will open, right, and break the circuit. The RCD will quickly realize, within a few milliseconds, right, realize that whatever I sent out is not what I'm getting back, and it will trip the circuit, open the RCD, right? So therefore, no current will flow through the circuit, right, because it will be open. And this summation current transformer, which is in the RCD, can pick up current as small as 30 milliamp. So just 30 milliamp flowing through that little boy, the RCD picks it up and said, no, something is wrong. What I sent out is not what I get back. So let me just open the circuit, right? And that, my friend, is the simplified version of how an residual current device works. So there you have it, guys. This was another video brought to you by Danai's Electrical Services. For similar videos to these, please feel free to subscribe to my channel at Danai's Electrical Services. Thank you, thank you, thank you.